Hi, everybody. Welcome back to the Feynman technique. Today we're going to be deriving a generalized expression for this integral right here, and we will be using the generalized expression for the same integral except without the squared there. I debated on whether or not to include this in my Power of Complex Numbers series, but since I really don't use that technique in this video, I included it in the Feynman Integration series, just my normal videos, because it does utilize differentiation under the integral sign to arrive at the expression. So let's go ahead and get started. So our first step is to just consider this integral right here, um, and just notice that these two things are equivalent. All right. So next we just make the substitution that AU is equal to X, therefore A is equal to, or ADU is equal to DX. All right. And then from there we get this. Just applying that substitution into this integral right here, and we get this. And now we will use the fact that we actually have a closed form expression for this integral from my last video. I will include a link to that video in the description of this one if you want to see where I get this result. The result is this. That integral for t greater than 1 evaluates to pi over t times sine of pi over t. Sometimes people write it pi over t times cosecant pi over t. Either way, it's the same thing. So next, well, we just, since these are all equivalent, we just say that this is equal to this, because this is equal to this, and this is equal to this, so this is equal to this times this, right here. All right. Now we employ differentiation under the integral sign on both sides, and we will be differentiating with respect to a. I'm not going to show the differentiation. Differentiation is a very easy process, so I'm just going to skip right to the results. And of course, this utilizes the Leibniz rule for differentiation under the integral sign that says that we can bring this derivative inside and just take the derivative with respect to a of the integrand right here. So what we get here, if we take the derivative of this, we get this. And if we take the derivative of this, of course, with respect to a, we get this. And then I just divide both sides of the equation by t a to the t minus 1. As you can see, I did that right here. All right. And then the next step is just to let a equal 1. And we now have our generalized expression for the integral from 0 to infinity of 1 over x to the t plus 1 all squared. And that is equal to pi times t minus 1 over sine of pi over t times t squared. All right, guys, I hope you enjoyed that, and we will see you next time.